All right. Well, we'll see. We'll see. I'll get them back to you. Okay. So, tangent. Tangent is a little bit different than sine and cosine, and therefore also the secant and cosecant, right? So, remember, secant and cosecant, we were able to use the fact that they were just the reciprocals of sine and cosine, or cosine and sine, respectively, I guess I should say. But tangent and cotangent, it's harder to kind of like, use those from sine and cosine. So we're not going to really like relate them to sine and cosine, although they do, right? Tangent is sine divided by cosine, and cotangent is cosine divided by sine. That's one way they relate to one another. But it's not super helpful to use that here for the graphing, okay? So I'm just going to instead throw some information at you here, okay? So for tangent, okay, its period, tangent repeats, in other words, every pi, okay?
So it's 0 cosine of the equal to x, which is less than pi.
Okay, so cotangent, yes, but for tangent, it actually starts. We're going to start it at negative pi over 2, and then go to pi over 2, because it's at negative pi over 2 and pi over 2 where the asymptotes kind of occur, and we're going to use the asymptotes to kind of help guide our starting and stopping points for these waves. For cotangent, though, that is right. It's going to be from 0 to pi. Okay, so this is one of the bigger things that you're going to have to remember, okay, about tangent, okay? Unlike sine and cosine, which both have a period length of 2 pi normally, which both start at 0 and go to 2 pi, and then you transform it, okay? Unlike that, tangent, it repeats every pi normally, okay? Starts at negative pi over 2, goes to pi over 2. Okay, now, with that bit of difference that we have to kind of remember, okay, with that bit of difference we have to remember, the basic graph of tangent is an easier graph to do than sine or cosine. Okay, tangent's graph, and I'm not going to, again, without like working through it too much or anything like that, okay, again, I'll put in the negative pi over 2 here, and we'll say this is just tangent of x. Okay, and I'll put the pi over 2 right there. Okay, tangent at pi over 2 is undefined, right? Again, think about it in terms of sine and cosine. Sine of pi over 2, 1. Cosine of pi over 2, 0. So you have 1 over 0, so it's undefined there at pi over 2. Likewise at negative pi over 2, because it's the same thing as 3 pi over 2, right? Negative pi over 2 and 3 pi over 2 are both coterminal. And so if you plug in 3 pi over 2, you're going to end up with the same thing. It's going to be undefined there. Okay? At 0, tangent is 0, right? Again, think in terms of sine and cosine. Sine of 0, 0. Cosine of 0, 1. 0 divided by 1 is 0. So we have this point, okay? Tangent of pi is 0 as well. Tangent of pi is 0 as well. Okay, we'll get out to there in a second here. Okay, but anyway, so what does tangent look like? Well, for angles between 0 and pi over 2, okay, tangent is going to go up like this. Okay, and then for angles in the fourth quadrant there between 0 and negative pi over 2, or you can think of it 3 pi over 2, it's going to go down like that. So it looks like a cubic. It's not cubic. It's not cubic, but it looks like a cubic. Okay, it looks like a cubic. That's tangent. Okay? And that repeats every pi. So if I want to do another full period here, I could go another pi out. Pi over 2 plus pi would get me to 3 pi over 2. Okay? The midpoint there would be just pi. And again, it would look like that. So notice here, what do we have to find if we're doing tangent or cotangent? Okay? If we're trying to find tangent or cotangent to graph it, you need the starting point of your period, you need the stopping point of your starting point of your period, stopping point of your period, okay? And then you need the midpoint, and that's it. You don't need the quarter points. You just need the midpoint, okay? The starting point and stopping point of your period will be asymptotes, okay? The midpoint's going to be your 0, or shift it up or down depending on your vertical transformation, stuff like that. And that's all you need. And you just graph a little shape there, okay? Yes, you might run across times when tangent has like a number in front of it, like a 2 or a 1/3. But if you stretch or shrink this, it's still going to basically have the same kind of shape. So I'm not too concerned about you trying to like worry about amplitude or like this vertical stretch or shrink there, okay? So don't worry about that. Now that being said here, now that we kind of have an idea about what the graph is going to be, okay, how would we describe the domain? Is the domain going to be all real numbers like sine and cosine? No, it's not, okay? So again, in this case, we're going to start out by saying all real numbers. And then we'll put except x equal to, okay? And so where's one of our first asymptotes? Sure, pi over 2. You can start with any of those. You can start at negative pi over 2, you can start at 3 pi over 2. I'm just going to start at pi over 2 there. I think that's good. Pi over 2. And then to find the next asymptote, what do we have to do to pi over 2? Plus pi or minus pi, right? Add or subtract pi. So we're going to say plus k pi, k is an integer. Okay, it's an awful lot of words there. I couldn't even quite fit it in there. There it is. Okay, all real numbers except x equal to pi over 2 plus k pi, k is an integer. Again, showing that every pi over every pi beyond pi over 2, every pi iteration before pi over 2.
Just put plus or minus pi.
Well, if we put plus or minus pi, that's plus or minus 1 pi. But remember, it goes on ad infinitum, right, or to infinity. So we have to account for that. Okay, what's the range here? What's the range for tangent? All real numbers. Yeah, all real numbers. Or negative infinity to infinity, if you like. Okay, so tangent has an infinite range, unlike sine, unlike cosine, unlike secant, unlike cosecant. Okay, all real numbers for the range there.
Sorry.
Got it okay? Question on anything? Figured it out.
Quiz.
Oh.
May I ask, is negative 1 pi the correct answer on the quiz?
Domain is x's, and I totally forgot that.
Domain is x's, that's right. So sine and cosine, all real numbers. Negative infinity to infinity.
So what would it have been?
Negative infinity to infinity for sine and cosine.
I was like, no, that one looks
That was
too
the other.
different from the other one.
Yes. For sine and cosine, negative infinity to infinity. Okay, so let's take a look here.
No.
Okay. Oh, I'll also talk about cotangent here real quick too. Let's just go ahead and do cotangent as well. Okay. So, like sine and its cofunction cosine, right? So like sine and its cofunction cosine, tangent and cotangent are very closely related. Their graphs are very similar, just with some subtle variations. Okay, so what are those subtle variations? Well, if we're going to talk about cotangent, its period is still pi. Okay, so it still repeats every pi. Okay, but it has the initial or starting period, what Rho was describing earlier, 0 less than or equal to the bx minus c less than pi. Okay, so cotangent is maybe the easier one to remember or whatever. It goes from 0 to pi, and then you can stretch or shrink, and then shift left or right based on, again, your transformations. Okay. So its graph,
To pi, not to pi, right?
yep, just a pi, because again, the period length is pi. So you start at 0, you're only going to go out pi until you start, repeating again. Okay, so I don't know. And again, at the starting point and stopping point of your period, that's where you're going to have asymptotes. So we'll have an asymptote at 0. Okay, and I'll go out to pi here. And we'll have an asymptote at pi. So just like tangent, where you have a starting point and stopping point for your period, and those are where the asymptotes are, same deal here. And again, you can reason it out by using the fact that cotangent is cosine over sine. Okay. At 0, sine is 0, so that means you'll be dividing by 0. And at pi, sine is 0, so you're dividing by 0. Again, undefined. Again, all we have to do here is find the midpoint. What's the midpoint between 0 and pi? Pi over 2. Okay? That is also a 0. Okay, so that's also a 0 there. Instead of increasing as we go from left to right, we're just going to decrease as we go from left to right. So it's going to look like this. and there's cotangent. And of course it repeats, so we could go out to 2 pi here, and say there's 3 pi over 2, and again that's a 0, and it would just decrease like that. Okay, domain is very similar here. It would be all reals except, in this case, since we're starting at 0, I don't need to put like 0 plus k pi. I can just say k pi. K is an integer. Okay, you can put 0 plus k pi if you want to, but it's not necessary, right? 0 plus k pi is just k pi. And what would the range be for this? All reals.
What's the domain?
Domain is all real numbers except x equal to k pi.
What range is Y's?
Correct. Range those in y's.
Mixing them up.
Yes. Think alphabetically. Domain comes first alphabetically. X comes first alphabetically.
Okay.
That's how I always remembered it.
That would have been helpful, like,
5 minutes ago, or 50 minutes ago.
30 minutes ago, yeah.
Years ago, back when you first learned domain and range. Think alphabetically.
This is something new. I was like, I don't get it.
Okay? So, there's cotangent and tangent. And I'll just show you one real quick, I'll just do one tangent graph, okay? Because the procedure that we're going to follow here is the same as our sine and cosine. So what's different, right, is just that instead of putting your transformations between 0 and 2 pi, you'll put it between negative pi over 2 and pi over 2 for tangent, or between 0 and pi for cotangent. You'll only find the midpoints, and then you just got to remember your shapes, okay, and stuff like that. So let's just do tangent of x minus pi over 2 plus 1. We can do it.
You can do it.
It's a Wednesday all over again.
It's what, Wednesday all over again?
Yeah, I did one problem in a couple minutes of class. That's what we did on Wednesday.
Well, when life gives you lemons, you graph trig functions. All right, so we're shifting everything up 1. So when I go to make, actually no, let me take care of this first. So again, we're talking about tangent. What's tangent's normal period? The tangent's normal period starts at what? Negative pi over 2. We'll put the x minus pi over 2 in between. And then where does tangent's normal period end? Positive pi over 2. Okay? We will solve by adding pi over 2 to both sides there. I'll zoom in some more there. Add pi over 2 to both sides. So we get 0 less than or equal to x less than pi. Okay? So that makes it a little bit easier, right? We don't have to worry about negative, x values here if we don't want to. Okay, so 0 to pi. And again, because we're talking about tangent and or cotangent here, the starting and stopping points of our periods have asymptotes. And again, if you don't believe me, just plug the 0 in. 0 minus pi over 2 is negative pi over 2. Tangent negative pi over 2 is going to be undefined. Plug in pi, you'll do the same thing. You're going to get undefined. Even if you add 1, right? Undefined plus 1 is still undefined. Okay? I also am going to graph in a horizontal dotted line through 1 because that's going to be my new center since I am shifted up 1 here. Okay? And again, for this full period, just find that midpoint. Halfway between 0 and pi is pi over 2. Okay? Plug in pi over 2. Pi over 2 minus pi over 2, 0. What's tangent of 0? 0. Plus 1 is 1. So at pi over 2, we go all the way up to 1. So there's our 1 point. Tangent, we know, increases from left to right. So go through that 0, that point there, and voila. There's your graph. Okay, if you want to go out one more here. Yeah, that's what cotangent essentially does. Or if you threw a negative in front of your tangent, it would then be increasing from right to left. Right? If you want to do a second full period, we can go out to 2 pi. Again, there'd be an asymptote there. Find the midpoint, 3 pi over 2. Okay. so on and so forth. Okay. So you had some tangent and cotangent graphs last night, right, in the homework. So I recommend you check those out. Okay, just check out the Google Classroom. What's that? Right. You're not going to be here. Yeah, we'll be learning about evaluating inverse straight functions. And then Thursday will be review day for the test. Yeah. So basically like going backwards. So now when I say, so what we did before, I was going to say like cosine 5 or 6, what's that? Now I'm going to say cosine of what gives me 30, or gives me, 3 or 2. So I'll be asking what the angle that linking the cosine gives you.
That's what we're doing tomorrow?
Yeah.
So you just use your reference triangle?
Yep, you can use the reference triangle. Can I teach you a question? Any set requests? Any set requests for today? Okay. Other set requests? Laura, do you want to come in? Yeah. Hey, great. Feeling better then?
Not really.
Okay. I was going to say, you seem to be doing better. So, higher spirits. So, you're good to come in, or you don't need to come in?
Well, I have that test.
Very good. No, I understand. Well, I mean, again, we can review it. We can review some stuff today and send it to you if you want to. Okay. Good morning, Mr. Miles.
Good day. I have some papers for you. You got quite a crew.
Oh, boy.
High flyers.
Yeah. Okay. Oh, shoot. Yeah, I guess I should deliver mine to.
I'll take it.
Yeah.
How is she doing?
Hang on a second. Hang on a second.
Sorry, I don't mean to look at you, but I'm going to. There's nothing you can do.